Good afternoon, everyone. Thank you very much for joining us today here. My name is Roberto Palacin from Newcastle University, where I'm a reader in Transport Futures and also contributor to this event. And this event is organized through the EPSRC network, H2 network for hydrogen-fueled transportation, which is part of a series looking at different aspects of hydrogen research in the transportation sector. And today we are looking at applications in the sector of railways. So we will be welcoming three speakers today on the subject of hydrogen and rail, of course. And they will give us some feedback from different aspects and different stakeholders in the applications of hydrogen, from Network Rail to Siemens, and of course, and some startups looking at transitional and very innovative technologies to bridge the gap between current propulsion systems and future key systems. We have asked a speaker to present for around 20 minutes. Without further ado, I'm going to introduce you the first speaker today, which is Stephen Hart. Stephen Hart from Network Rail. It is part of the team that has developed the hydrogen strategy for traction, the TDNS, the traction decarbonisation strategy. I let Stephen introduce himself and give us his interesting presentation on the views of Network Rail. Stephen.
Thanks, Roberto, and thanks for inviting me along today. So hello, everybody. So I'm Stephen Hart, lead strategic planner within the Network Rail system operator freight and network strategy team. So me and my team principally look after the long-term strategic planning activities for the rail freight industry. And as part of our role as kind of looking over the whole network as well, we also pick up pieces of long-term strategic planning called network strategies, which are pieces of work that impact more than 3 of Network Rail's regions at the same time. And most recently, over the past couple of years, as Roberto has pointed out, I've been leading a piece of work called Traction Decarbonisation Network Strategy, looking at how we remove diesel trains from the network. So today, I'm going to talk to you a little bit around specifically some of the things that have been going on in the rail industry around hydrogen traction. And some of the more detailed aspects of hydrogen traction and kind of where we believe it will be applied, and the sort of areas that we need to consider moving forward as we consider the application of hydrogen as a rail traction solution. I'll be picking up on the questions that you can see there, and we'll be going through and discussing some of those items in detail as we go through, and covering off various different aspects of the application of hydrogen within the rail traction. I thought as soon as I was first up that I'd set a little bit of context and provide some background. I appreciate there's a lot of people on the call who will probably know most of this stuff and see some of this stuff on a regular basis, but I thought I'd provide an overview seeing as I was up first. So hydrogen's in rail to date. There have been a number of applications within the wider rail industry, not within the UK, but on a global basis. We've seen the first hydrogen rolling stock operating on rail over in Germany. And you can see there a picture of the island over in Germany there, which can carry 150 seated and 150 standing passengers. It has a range of over 1,000 kilometres and can operate at speeds up to 140 kilometres an hour. Those trains have clocked up almost 200,000 kilometres of running now. So that train's been in service for a number of years, and we've seen some good, reliable kind of regular running from that, and a significant kind of volume of mileage accumulation that come out of it. As a result of the success of the introduction of those units, further units have been ordered in Germany, and there are also orders in place for Italy and France as well. As well as that, and a bit closer to home, earlier this month, Alstom, in conjunction with Heavyshort Rail, announced a memorandum of understanding to develop 10 3-car hydrogen multiple unit trains for the GB network. So they'll be based on the latest Alstom Aventa platform, which is seen on a number of commuter trains across the network today. That they're obviously kind of going through lots of conversations at the minute, and various different pieces are going on there, but it's envisaged that final contract should be signed within 2022, with the units likely to be delivered a few years after that's been achieved. As well as that, there are a number of other hydrogen demonstrators being developed through Porterbrook and Arcola Energy as well. But currently they're kind of just focusing on the technology and retrofitting that technology into historic ex-BR EMU trains, to understand the complexities and challenges that technology brings, and kind of how we go about doing a retrofit and making sure that we're learning and upskilling and understanding a lot of the challenges and complexities that we can have from deploying hydrogen on the network. So looking at a little bit more at the capability, so most commonly the proposals for hydrogen trains on the network are electric trains, which carry hydrogen, fuel cells and batteries in order to provide the kind of electricity that the train needs. The vast majority of trains on the network, certainly new trains that have been introduced, are all essentially, the basis of them is all an electric train. It's just about where you get the electricity from, essentially. Hydrogen in those trains is currently stored at around about, is currently stored at 350 bar pressure, and at that pressure, to obtain the same amount of energy as you would diesel, basically, the volume of fuel required is about 7 to 8 times larger. So as you can see, hydrogen as a fuel in itself is not an especially energy dense fuel. And given the kind of challenges that we have on the UK gauge network, UK rail network around gauge, there is obviously a challenge around fitting greater and larger volumes into the kind of envelope that we have available to us on our network. Train operation is usually up to a range of around 1,000 kilometers, but that can be very dependent on tank size, weight, and the kind of topography and the operational needs of the train in question. And refueling a train of that sort of size would take around about 15 minutes. As I mentioned, the limited loading gauge for the UK network means that we typically need to find and have kind of hydrogen storage tanks which require space to be taken up. For passenger trains, that normally means putting the tanks in the saloon, although there are opportunities to utilise space in and around the train within the gauge envelope, depending on what the train's doing and the size that the train is. But for freight, a hydrogen locomotive's likely to require kind of at least one, if not two, kind of fuel tender wagons, which kind of have the hydrogen fuel contained within them. And that would subsequently displace what are called commercial wagons within the consist. So the rail freight industry works on an entirely commercial basis, so every wagon kind of makes money basically, and the freight operators often refer to the last wagon as being the wagon that makes their profit for them basically. So displacing commercial wagons out of the consist for a freight locomotive is considered commercially challenging and in most cases commercially unviable. As a result of the space take, it's unlikely, certainly in the current configuration and current setup that we have within the industry and within the network, that a commercially acceptable solution will exist for freight due to that very need to displace commercial wagons. That being said, there are a number of examples of hydrogen freight locomotives in development around the world. Although those examples tend to be on networks which have less space challenge than we do, and often have greater ability and much longer trains. So you can see the one on the top there is a locomotive that's been developed in Canada. There is definitely a role for hydrogen within various different aspects within rail, and there are certainly a lot of questions and a lot of examples and a lot of work being done to understand the role that it can play. And I think as the technology continues to develop and continues to emerge, we will begin to see its application in an appropriate way. Although that will need the support of kind of government and the support of the industry to implement it successfully. As well as that, the use of hydrogen through different technologies away from fuel cell technologies, such as through combustion, is a potential solution. And there are a number of organisations from outside rail currently that are beginning to look at that as a potential solution. It is possible that hydrogen could have a role to play in shunting activities. So you can see on the bottom there, it's a hydrogen-powered shunting vehicle that's been developed in China. And there is a likelihood that where electrification can't be provided in kind of freight terminals and yards for operational purposes, and we need to achieve zero emissions vehicles in those areas, that hydrogen could have a role to play, given its relatively higher duty cycle compared with battery. In the short to medium term, there is certainly a role to play for hydrogen trains, specifically for those areas of the country where electrification is being proposed as part of the long-term solution. But that electrification won't necessarily be delivered in a kind of at the early stages of the rolling programme that we've proposed as part of Traction Decarb Network Strategy. There will definitely be areas of the country where electrification will be happening in the kind of 2040s, 2050s, etc. And as a result, if we can focus on removing some of those diesel trains that are operating in those sections today and replacing them with a credible zero carbon solution, that at least removes the diesel until a full electric solution can be found in the future. Can be deployed in the future, sorry. Hydrogen definitely has a role to play within that, and we've modelled a number of areas within the network where we could deploy hydrogen as an interim technology and shown that that has a positive impact on the overall business case. The biggest challenge that we probably face from a rolling stock perspective over the next few years is the impending life expiration of the 15X and 16X vehicles. And it's likely, well, it's almost certain that the replacement of those vehicles is not going to be achieved through the deployment of electrification alone, especially given the areas of the network where those vehicles are typically deployed. It's likely that no new diesel trains will be able to be bought because the financial arrangements from a rolling stock procurement perspective that we have on our network in the UK will mean that finance will be difficult to attract and will be an unattractive proposition for those investing. As a result, hydrogen, in conjunction with a blend of other solutions, including cascading diesels from those areas of the network where electrification is provided, and the introduction of new diesel electric bimodes and battery electric trains, will offer the kind of optimized solution for the replacement of the 15X and 16X fleet. As well as that, rail can act as an anchor client for hydrogen, with regular repeatable volumes of fuel required based on the kind of timetables that we operate. It could offer a kind of credible and meaningful volume that could attract other sectors of the economy in and create a kind of foundation for the development of a wider hydrogen economy over time. Whether that's regional or national is a challenge, but rail can definitely act as kind of an anchor client with the kind of regular repeatable volumes that we need. So where do we need hydrogen in the long term? The map on the right here shows the outputs from the Traction Decarbonisation Network Strategy, where we've proposed of the 15,500 single track kilometres of unelectrified network, around about just over 13,000 single track kilometres should be electrified. But there is definitely still a role for hydrogen within the network. Within Scotland, the distances involved in the lines on the far north, and also from Glasgow towards Oban, Fort William and Mallaig, the distances involved are unsuitable for battery traction. And given the challenges with electricity provision in the termini, it's highly unlikely that recharging would be able to be provided in a credible and meaningful way. And it's likely that hydrogen will play a significant role in these areas going forward. Within the northeast and northwest, these are areas where electrification is likely to be delivered towards the end of the programme, given the relatively lighter usages of the lines in question. And as a result, deployment of hydrogen vehicles in these areas could be a useful interim step to remove diesel emissions today and support overall emissions reduction from within the industry. Similarly to within Scotland, within the heart of Wales, the distances involved and the challenges around provision of a meaningful electric source in terminized stations, it's likely that hydrogen will be the preferred deployment solution for Wales, for the heart of Wales from Shrewsbury towards Pwllheli and Aberystwyth, as well as from central Wales down to Llanelli. Within East Anglia, the case for hydrogen is a little less certain. The distances involved is kind of a real kind of tussle off between battery and hydrogen. Currently, as it stands with the technological capabilities of battery and the kind of operating profile of the network in question there, as well as the kind of turnaround times and various different challenges, battery becomes a difficult thing to try and implement within the Anglian network. Also, with the likely proposals of a hydrogen hub within the Lowestoft area, there is a potential that hydrogen could become that anchor client for such a facility. So as we've seen, there is clearly a role for hydrogen in the short, medium and long-term basis as well. It's likely that hydrogens will exclusively be used for regional passenger services unless a realistic commercial proposition can be developed for freight that doesn't require the loss of commercial wagons to provide a fuel tenders. Equally, the impact of revenues on long-distance high-speed services from a loss of space within the train to provide hydrogen provision for trains that are travelling over such large distances and the high energy requirements that means that it's unlikely that a long-distance high-speed train could work commercially. Although, given changes in technology, this may change. Rail can certainly act as an anchor client for much bigger refuelling systems to support the decarbonisation of other sectors, including buses, HGVs, cars and shipping. And there are a number of proposals around the UK now where this is becoming commonplace, where hydrogen hubs are being proposed. As well as the use of hydrogen within the rail industry itself, we also need to be cognizant of what the wider hydrogen economy might look like in the UK. And that may well dictate whether or not the rail network itself could be used to transport hydrogen around the UK in order to provide it for where it's needed. Hydrogen as a commodity could be just as significant in the long term as coal, oil, and petroleum have been historically, and the rail network has a long history in transporting critical fuels around the network, around the country, in order to achieve the power demands required. Overall, within rail, 4 key areas where there are challenges around hydrogen which we need to think about. Safety. There are various different things around safety, including the various state pressures, as well as kind of the volume of fuel that can be stored in any one given place, given the kind of safety implications and safety challenges that we have for storage. We also have to give consideration for kind of safe systems of operation when operational incidents occur and how hydrogen would kind of react within those situations. There are a number of wider policy areas where we need to where there are challenges, and we need to consider various things, including which sectors of the economy are going to use hydrogen, how that hydrogen is going to be manufactured and imported, and indeed how that is going to be transported around the country, with rail offering a potential way of achieving that. As well as that, future costs for the volumes that are going to be required, and changes in taxation policy as we move away from using diesel fuel towards moving towards greener alternatives. The government is likely going to want to replace diesel tax with other taxation on green fuels also. As well as that, we need to think about whether hydrogen is going to be delivered in regional clusters or whether it's going to be approached and looked at within a national scale. Rail itself is only likely to be a limited contributor to the use of hydrogen, so the size and scale to develop bespoke products is limited, and it's likely that any proposals that come forward from any of the train manufacturers will be a traction optional extra package on their existing rolling stock provision that they have from their electric multiple unit fleets. Equally, there are challenges, as we saw in Anglia, around kind of the competition of technologies with each other, and battery, hydrogen, and indeed biofuel are even in competition with each other to an extent. And the challenges around kind of which of those technologies may win out in certain circumstances is as yet unclear. The technical capability itself and the challenges that that poses from a kind of commercial and operational perspective means that as it stands today, long distance high speed services and freight activity, significant rail freight activity is unlikely to be yielded and unlikely to be realized through the use of hydrogen traction, with a much stronger focus on regional and suburban type services. That's due to the relatively poor energy density and inefficient kind of fuel process, the energy process through the kind of transition of the fuel through several stages, and the larger volumes that are required to be stored within the kind of limited GB gauge that we have. Going forward, there are a number of areas as an industry that we need to focus efforts on. We need to focus on getting hydrogen passenger trains into operation so that we can learn and embed the best practice from those and from that into the future rollouts as we roll out more and more of these trains on the network as a whole. We need to continue to jointly develop standards and operating procedures for the safe operation of hydrogen rolling stock on our network, in conjunction with the work that's been going on as part of the technical developments and the proof of concepts that exist today. We also need to ensure that passengers are actively aware of and buy into hydrogen traction. That is likely to need us to undertake a campaign of kind of education and promotion in order to show and demonstrate to passengers of the network that how the hydrogen traction system works, and that they can ultimately rely on it, and that for any kind of safety concerns are unfounded. We need to work within the wider rail industry and other industries to bring forward credible hydrogen refueling infrastructure that can be used to support and facilitate the hydrogen refueling of several users in order to achieve the economies of scale that need to exist in order to make hydrogen a commercially viable product as it stands today. And we also need to work alongside the government to understand the role of hydrogen as a commodity and how we could accommodate this on the network, including the various aspects that we need to think about in what that means from an operational perspective. I hope that's been useful, and I hope that's given you a good insight and an overview of some of the considerations we've made and are making currently within the wider industry around hydrogen, and some of the challenges that we're facing as an industry as a whole. And I'm sure that the following speakers will kind of build on a lot of these aspects and explore some of them in much greater detail. And I look forward to the questions at the end.
Brilliant. Thank you very much. Thank you very much, Stephen. That's very interesting.